In this video, we want to integrate tangent x times secant squared over 3 plus tangent to the fourth x. So first I'm going to do a u substitution. I see a tangent and a secant squared, so I know the derivative of tangent is secant squared. So let u equal tangent of x, du is secant squared dx. So the top becomes u du. The denominator I have 3 plus u to the fourth. From here, I'm going to make a substitution, and the goal is to get into a trig function or inverse trig. So with the inverse trig functions, like in this case I have a plus, so it would be nice to transform this into like 1 over 1 plus, let's say like x squared, because I know that's just going to be inverse tangent of x. So we have to do a couple substitutions to get it in this form. The first thing is, let's reduce the exponent here to squared. The way we're going to do that is by letting s equal u squared. So then u to the fourth is going to equal s squared. And now ds is equal to 2u du, so u du is ds over 2. Okay. So u du is ds over 2, and then the denominator is 3 plus s squared. From here, I have, let's say, the x squared, but I need to get rid of the 3. But first I'm going to factor out the 1/2, and then I'm going to factor out the 3. So I have 3 times 1 plus s squared over 3. And now this 3 comes outside the integral as 1/6. And so we have integral 1 over 1 plus s squared over 3. Now the goal is to get rid of this 3. I have x squared here. I want to get rid of 3, so I have to make another substitution. So basically I need to substitute something in for s, and when I square it, it becomes 3. So think of it like the square root of 3 will be square root of 3. So we're going to introduce p. P is going to be s over the square root of 3. Or if you can think of it like s is square root of 3 times p. Okay. And so ds will just be root 3 times dp. Okay, so now we substitute root 3 times p for s, and then root 3 dp for ds. Now when I square root 3, it becomes 3, and that's going to cancel with the denominator. So I'm left with 1 plus p squared there. And then the root 3 will come outside, and we're going to have root 3 over 6. Now I can integrate 1 over 1 plus p squared as inverse tangent of p, and then plus c. So right now there's no more integrals, so I have to substitute back. We said p was s root 3, and now we need to substitute s. S we said was u squared, and then u we said was inverse tangent. I'm sorry, u was tangent. Okay, so u squared is tangent squared. Finally, I can simplify root 3 over 6 because 6 is just 3 times 2. And so I guess you can also think of it like root 3 times root 3 times 2. One of the root 3 is going to cancel, and so I'm left with 1 over 2 times root 3, and then multiply that by the inverse tangent of tangent squared over root 3 plus a constant c. And that is my answer.